the conundrum, of course, is how do you put all the benefits of what people see in a smartphone or the glitzy color displays with the cost and low power in the embedded space. So we're going to talk about some options and some trade-offs, and we're going to talk about an Element 14 board as an example, and we'll have a demo of that one that we've used with one of our microcontrollers with graphic LCD interface. Shipping in the embedded space, segment LCDs, whether it's 7 segments or there's 15 or more segments, are obviously a little bit easier to deal with. It's really more like your old TI watch back in the day, right? As you move into the higher end graphical space, people who are used to smartphones now, people who are used to these color displays, the conundrum is how do you add this in the embedded space without breaking the budget, without breaking the power issues that we have, and this is what we're going to talk about. We have multiple products that have the same IP block, and we'll talk about that. But there are different trade-offs for you as you move forward. Certainly, segment is still an option. If lowest power and lowest cost is an option and you have to have some graphical display, you might consider a segment LCD. But we're going to assume that you want to add a little bit more color, a little bit more vibrant display, and we'll talk about that space. Right. Now, in the embedded space, there's a lot of different applications, and this is just some examples. So you might add a display to your washing machine. So we're starting to see more and more of that. Tend to see more of that in Europe right now, but it's coming here in the US as well. You have a blood glucose meter, might be an example where you want to have a little bit more of a graphic display, some industrial controls, point of sale terminals. What's not on here is maybe a guitar effects where you want to have a little bit more control, or in the audio side. So a lot of different great examples of how you can add this. Now what this doesn't do for you is full motion video, HD. You're going to push up into the application space if you're interested in that. So if you're interested in 1080p or some of those spaces, that's not what you're going to be able to cover in the embedded space. You're just not going to get that resolution. There's a trade-off. So if we're kind of in this space, in the 320 to 200 or up to the 1024 by 768, which is a really nice display still, maybe 15 frames per second or less, depending on, certainly push buttons, nice color backgrounds. We actually have a demo by a company, FDI, that has used one of our parts for 15 frames per second video. So if you're interested at the end, we can show you what that looks like. And it looks pretty good in that little display there. So that's probably the most performance you can get out of in the embedded space. Right. Okay. So a couple ways you can do this, depending on the LCD you're interested in. We do have customers that are using, in the Cortex space, no embedded controller, but an LCD panel that actually has the controller built in. That might be simple and from a lower resolution point of view, but you're gonna lack a few things in terms of bandwidth. You're not gonna get the 15 frames per second or some of the color resolution that you would get if you had the LCD controller built into the part. Both work well. We have customers using both, but in this space we're going to talk about the idea of having the embedded controller built into the part because it just gives you higher resolution and more bandwidth in terms of some of your choices. You may or may not need external SDRAM depending on the resolution. We have an external memory controller here that allows you to add that fairly easily. You probably want your frame buffer in there if you're doing 16 or 24-bit color. You don't have to. What I didn't show here is there's a new interface that we have, SPiffy, that Vandana will talk about, that allows you to take large amounts of images in an inexpensive space and directly DMA them out to the LCD controller. So you can actually do something along those lines as well. Okay, so assuming we pick the LCD controller built onto the microcontroller, what are the characteristics of those parts? Well, I mentioned the resolution up to 1024 by 768. Certainly there's a trade-off. The more bits you have, the more SRAM you have to have. The more bits you have, the more trade-off in number of frames per second you can get. So those are all sort of trade-offs. Typically, we don't see people use that high resolution. 800 by 600 or below is what we tend to see in this space, but there's some certain trade-offs in terms of memory and frames per second, as well as resolution. I'll talk about the multiple parts that this IP block is on, but the good news is this IP block is the same across multiple microcontrollers. And there's different features in the microcontrollers. If you want I don't want to call it low end, but if you want the The M3 with the graphic interface, that's the 1788. Full speed USB, Ethernet, etc. If you need high speed USB, we have some parts there. If you need more flash. So there's different trade-offs, but the IP block we're talking about is identical on all those blocks. So whatever you learn in terms of the capabilities of this IP block will be the same on all the parts. To make it simple, we're going to talk about software. You don't necessarily have to use it, but we do offer in any of our microcontrollers a package from Sager. You get a free graphics GUI for creating your own interfaces. There are other choices we'll talk about. Java is one of them from other companies. .NET is one of them. And there's other people with GUI interfaces. We also have other free libraries. We try to make it simple for you and give you many choices. So here are some of the parts. Today we're talking about the 4300. It's a Cortex M4 part. How many people feel like they're pretty knowledgeable what a Cortex M4 is versus an M3 versus an ARM7? Pretty knowledgeable? Okay, or should I go quickly through what it is? Is that knowledgeable or go through it? Okay, all right. So ARM7 came out some number of years ago. NXP, we've been doing ARM-based 32-bit micros for a very long time. The ARM7 is just your solid microcontroller. The ARM9 is more of an application processor. If you want to do high-end Linux, you would use an ARM9. It has a memory management unit, typically. So ARM said, great, ARM7's great. Let's reduce the power, increase the speed. We came out with the Cortex M3. So think of the Cortex M3 as the replacement for the ARM7. I'm kind of oversimplifying, but that's basically the way to think about it. So if you're moving forward, you want to look at the Cortex M3 for a nice solid microcontroller. The Cortex M0 is a cost-reduced version and a power-reduced version of the M3. Code compatible, but low power, low cost, you'd look at the M0 or now the M0 Plus. The M4 is basically everything the M3 is, plus some single cycle multiply accumulate. The intention was kind of push into the DSP space a little bit. So good for graphics, you know, if you're interested in that, because you can probably do more math processing than you would on the M3. You might take 3 to 7 cycles to do a multiply accumulate in an M3, 1 to do it on the M4. There's some SIMD instructions, an optional floating point unit, but essentially all the M0 code will run on an M3, all the M3 code will run on an M4, so there's a lot of reuse of IP. One set of tools will work on all those cores as well. So just a very quick overview there. The ARM9s have more or less gone to the Cortex A space, is what's in your cell phone, right? The high-end application processors. You want to do 30 frames per second, full motion video, you want to look in those spaces. But here at NXP, we're focused on the Cortex M. Quickly, so on this page, and we're videotaping this, so in fact, if you forget what I said or you want to go back and check, within a week or two, this will be on our YouTube channel. You'll be able to go back and see the videotape of this session. 1788 and 4088 are essentially the same part. One's an M3, one's an M4. 1850 and 4350 are also pin compatible. M3, M4, higher speeds. We have the fastest M family out there at 204 megahertz. The external bus, however, will only run at half that speed. And in many cases, you might want to run the core and the external bus at the same speed because the external bus is usually your gating item for your frame buffer going out to the LCD. So there's some trade-offs there to look at. Okay. Yeah, go ahead.
You're saying tool comments that apply to all of the 2100?
Yeah, I'm sorry, go back for a second. Yeah, our 2000 family is an ARM7. This is an ARM9 family. It depends on the tool. Typically, Kyle or IAR on the high end, or see a lot of people gravitate, and they'll, you know, anybody who has a Cortex or an ARM7, ARM9 will have support for that. I don't know from a tool point of view, when they went from ARM7 to the Cortex M, and these are all Cortex, they did change the instruction set. And by changing the instruction set, it's a little bit of work in recompile. So it's not a tremendous effort, but there is some effort into recompiling. You probably, if you're using those tools, can have access to all these, depending on their licensing models. We do have a tool called LPC Expresso. It's based on the Code Red suite. We had a Code Red session here as well. That is free for the first 128K of flash. So that is something you might want to download. It's Eclipse based. So it's something definitely worth taking a look at as well. Okay. Great. Okay.
So I just wanted to talk to you. Again, my name is Vandana. I'm from Element 14. And what we did is we worked very closely with NXP to build a development platform for their 4357, LPC 4357 controller. And what I wanted to walk through was some of the typical design parameters, configurations that you go through while actually designing an LCD or a graphics display for your typical embedded application. And again, to reiterate, it's again for embedded systems, so it's not going to be your MPEG-4 30 frames per second kind of graphics. So firstly, one of the important things is choosing the right LCD resolution. And again, resolution does not mean size when you're doing for graphics, right? So you could have a 4.3 inch, you could have a 7 inch, or even a 2.5 inch LCD, but with the same resolution, whether it's a QVGA or a VGA display. So first is, what does your application need? Typically, for the blood glucose meters that we showed up earlier, a 320, a QVGA kind of resolution is really, more than enough. So that's what we decided. We took a panel, a 4.3 inch LCD, comes with our board as a bundle, and that has a QVGA resolution. The demo is running right here, and we'll focus a little more on that later. And the resolution is really determined by the number of pixels, right? The X and Y. So how many pixels can it actually display? And the second important factor is the color depth. How many bits per pixel? So the controller itself, the LCD controller itself, internal to the NXP, both the 4300 as well, 4357 and the 1788, can do up to 1, 2, 4, and 8 bits per pixel, the color depth itself. So both these parameters will, and what that kind of translates to is a much richer, in terms of color, display on your actual LCD, able to kind of deal with fast graphics, little more intense in terms of, suppose you're doing say a waveform or something, an audio analyzer, for example, you'd be able to see the different colors more clearly. So the other thing I wanted to showcase here is, so we were talking about color depth or bits per pixel. So this diagram here just shows a 555. That means there are 5 bits for each of the RGB colors, right? And you could have different configurations in this. You could have a 565, so that means the red has 5 bits, the green has 6, and the blue. You could have, the utmost would be an 888 or a 24-bit kind of resolution for the color depth itself. So one of the other ways to kind of display an image is by means of a lookup table within the controller itself. And what happens in that case is the frame buffer basically is filled with index values. And each of those index values refers to a certain kind of location in a RAM, a palette RAM, and for a certain color to display. So the frame buffer is filled with the different, what your image needs to represent, right? The actual colors and everything. The controller itself takes a look at that index value, matches it to the RAM, the palette RAM, and then displays that corresponding image on the display itself. So for example, if you see on the left corner, it shows a value of 3, index value of 3 in the frame buffer. It matches the palette, which is that light blue kind of color, and that's what's displayed on the image on the top left corner. And the same thing happens. So the controller, LCD controller, does this matching from the frame buffer and then displays that image onto it. We'll talk about a little bit about the SPiffy interface and how that happens, and it really just directly loads an image from the LCD controller directly onto the display via with the help of DMA. So again, just another note is you can go up to 8 bits per pixel in terms of the color palette for displays for the NXP LCD controllers. And this is really talking a little bit more about the SPiffy interface that is on the LPC 4300.
4088, 1800, and 4300 all have this new interface to Quad SPI flash.
Yeah, so and what it basically does, one, it's a Quad SPI interface, and it actually showcases the external memory, a Quad SPI flash memory, and it maps it just as if it would be internal memory, internal flash. So the 4357 itself has 1 meg internal flash as well. But then in order to, our board right now supports 256 megabytes of flash RAM. And what it does is, through the SPiffy interface on the LPC4357, it takes the image or a picture directly from the flash and displays it onto the LCD controller with DMA. So what happens as a result of it, it's fast graphics. There's no load on the CPU, so you have enough bandwidth to do the others. And then again, it's a dual core, so you could actually use that for communication, the M0 for, say, loading a file via USB, doing some audio conversions on that side as well. So the next step, okay, you've decided what resolution you want, what color depth you want. Now it's like, what kind of an LCD would you want to use? And now most commonly for embedded systems, of course, we are focusing on TFT displays. I mean, the price points have come down to a level where everybody is kind of tilting and going towards it. But what is really the difference between SDN? Why would you choose a TFT versus SDN? Definitely faster response, I think, is one of the key factors for a TFT display as compared to an SDN, which is what we call a passive display. The TFT, a thin film transistor base, is an active device, so the response time is much faster to display the graphics. From a viewing angle perspective, the TFTs have a wider one. Typically, the SDNs one have around 15 degrees at the max from a viewing angle standpoint. The key, I guess, limitation for a TFT is the cost. They haven't still been driven down to the cost that most applications can use. So SDN, if you're looking for a low cost, and depends what kind of display you want, which is just say a digital, you're just displaying some numbers or keys or something, that's probably the way to go for an SDN. But if you want high graphics like pictures, even just doing a still picture frame, for example, you would rather go with a TFT display. And some of the other I guess, comparisons between a TFT and SDN is shown here. There are other display types available, like an OLED, organic LED, LED display. They, again, are more expensive. There's another display kind called the CG, that is the continuous grain silicon displays, where the pixel size is smaller, so you have a better resolution. But then that, again, as the better the technology gets today, of course, the price is definitely a factor to consider. So one of the interesting, I think, support areas that you can access for the 4300 itself is at lpcware.com. It has a lot of the software drivers, demos that are available to support this chip. And one key utility that you can download from there is what they call a Busload calculator. For example, so you're using these graphics. You know how many bits, what the color depth is going to be, right? What your resolution is going to be. You just input these key parameters into the spreadsheet, and let me see if this works here. And it automatically calculates for you what the load on the bus is going to be, right? So here, you're going to put your clock rate for the external memory controller, right? They put the bus width and so on. And at the bottom, oh, maybe not so bottom. Once you've keyed in the key parameters like color depth, refresh rate like 60 hertz, then you would see the bus bandwidth, the summary is shown as bus bandwidth needed. So you need for example, the 6.2% is what the static external memory will be using, loading the bus with. That's the amount it actually uses, and for the dynamic. So you can change these parameters, calculate that, and then all the rest of your demos or applications that you will build, you can proportion or at least estimate how much of the bus you would use for that. So it's running at, here we have said the external memory is running at 120. Is that the maximum for the EMC? Yeah, so it's running at maximum speed, the EMC at this, when we've made these assumptions. So this is a really, really, useful utility, and there are many such. There's also drivers for, the emWin graphics library, which I'll touch upon, but LPCware has really got good utilities and tools for you to download. Whoops, sorry. The next, what we'll discuss is a little bit okay, so we've discussed what we need to configure, but with the LCD itself, what are the key steps to configure it? So like you see on the right side, I'm showing what you call a landscape format for the display itself. So key things to configure would be the horizontal and the vertical timing to make sure that the white space is configured and the front porch and the back porch is adjusted accordingly. You need to generate the right clock and signal polarity and the control words. Next would be, depending on what kind of panel type you're using, whether it's a TFT or STN, you need to set that within your code. And depending on, again, on the LCD panel that you use, you need to set the clock rate as well. The color format, whether it's RGB or BGR, and of course the color depth, so number of bits per pixel. So this is the platform that we built based on the 4357, and the resolution can be selected to even support up to 1024 by 768. That's the internal LCD controller can go up to that, an XGA kind of resolution. And you can support up to 24 bits, so the 888 configuration for RGB. And it's got an on-chip, that means within the chip itself, it's got a 512 byte color palette. For a color depth, NXP supports about 256 entries. So the internal color palette does come in handy. And the display here, it's kind of an optional bundle. So we have two part numbers. One, we sell the baseboard by itself for you to adapt your own display types if you've already got some that you're using. But we also have the option to bundle it with a QVGA LCD, 4.3 LCD. So this is just a block diagram outlining what this board is highlighting. And the key part here is, like we mentioned, the Quad SPI flash. So it's got the 256 megabit from Spansion. It's got the LCD connection on, and that's a 24-bit data line going into the LCD. It supports touch screen via an I2C. It has also got the NXP audio codec on board. So if you wanted to do something, from an audio video kind of multimedia application, say for, industrial controls, for example, this would be a good board to use. We have a USB host. And the 4357 has an internal PHY built in for that. It supports the SD card. We've of course given some user keys for you to do your I/O. Joystick, it's a nice simple joystick for you to use for navigation through the graphics library that we have on display here. So now, just want to touch on, you've got the LCD, what's the best way to actually, and from a development platform basis, we said we need to pick a certain graphics library to really showcase the key features of it.
NXP is partnered with Sager. They have a graphic library called emWin. And emWin, if you buy an NXP microcontroller, with or without the graphic LCD, you can get emWin libraries for free. That doesn't include source code, but it has everything you need for the GUI to go and build your own graphical interface. So very nice package. I don't know what $12,000 or $20,000 it costs normally.
And you get it free.
Yeah. Swim is a very low cost package that we give away for free if you go to lpcware.com. So nxp.com is a great place for data sheets. LPCware is our engineer to engineer site. Schematics, example code, go there. There are a couple other options as well. So Altea is an example of a higher end system that if the way it looks is most important to you, or you want to pay somebody to do it for you, consider somebody like Altea. IS2T. They basically have a Java translator. So if you're familiar with Java on the PC and you have something you want to easily translate for people who don't want to do embedded code, that's another option for you. And .NET is another option. GHI is a company that has that. So there's other ways to use the graphical interface, but I'm assuming at Embedded Systems Conference, DesignWest, we're in a room full of guys who like to do embedded design, so you might want to, we'll focus our time on this emWin. Yeah, Sager.
Yeah, and so that's the one we picked because our target audience is really the embedded design engineers out there. So, as Gordon just said, it's free to use with any ARM, NXP MCU, not any ARM MCU. It supports all types of LCDs, SDN, TFT. It supports all types of color depths, all color display types like monochrome, grayscale, color, active, TFT. And I think the relationship is extremely strong with NXP, so they have support built in for NXP, which is very easy to port onto a platform like this. Board support packages for this particular board, we've released our board support package, which also includes a emWin based demo, which has its source code. We've had help from NXP and Mahesh and the team to do that, porting over and optimizing the performance in that. And emWin itself it's not only restricted to NXP, so you could use the same library with other MCUs and other display types too. So one of the key features I wanted to highlight in emWin really is the widgets. So these are really like window objects that you can, and they have widgets for everything, like if you want to do a slider, you want to do a button, you want to do some graphs, and so on and so forth. They have these preset pre-configured widgets that you just need to take and then embed it into your code. And then adjust the size or whatever, you can actually customize it to your needs. So this is extremely, extremely useful, especially if you're building a certain display type. Again, I suppose you're doing like a scroll bar. You take that widget. Here I've kind of done a drop-down box example here. All you need to do is just take these few lines of code, embed it in yours, and compile it, build it, and deploy it on the board. And it's ready to use. So it's extremely user-friendly. It's easy to use. It's configurable. It's got various widgets on it. I mean, I've just listed a few. There are many more. So I think that's one of the key reasons. I mean, we also picked emWin. We've seen a lot of end applications using this to do like controls for air conditioning and your internal. We've seen a lot of application using emWin libraries there.
Just want to show you some Java examples of what graphics look like. Again, if you want to translate Java, the intention is you would save money. You might spend money on the Java, but you'll save money on the development costs because it's a lot faster than spending months to get your own interface looking just right. So ISQT is something to consider. And then Altea, if you wanted source code, you don't get that with the emWin libraries unless you go to Sager and say, okay, I want to pay extra for the source code. Once you do that, you may want to consider a package like Altea as well. They really kind of focus on the brand building, C source code, and they have services. If you just want to pay somebody to do it for you, that's an option as well. In both cases, they have demos. They started with a 1788. We're showing the high-end part now, but the 1788 is a great part for graphic control. If you don't need the M4, if you don't need high-speed USB or dual core, start with that one and then go up from there if you need extra capabilities.
And maybe we can just wrap up and then we do the demos for
Sure.
both the 1788 and...
But, sorry, having said that, this is a great package with the Quad SPI.
Thank you.
And the 4357 is a great choice.
So just we talked about lpcware.com, but for this board in particular, the LPC 4357 EVB that Element 14 has come up with, there is our own community site where we've posted all the design files. So, kind of going on that open source behavior, so all the schematics are there, bill of materials if you want to take a look at it, and most importantly, all the demo software. There's all the codes. You can go to that URL that we've pointed out. So not only on the emWin, we have others, like I said, displaying with the SPiffy interface, just static pictures on for the board. Yeah, the board with the LCD is $112. And we sell the board alone also for $95. If you don't want the LCD, you want to use your own, we do have that for $95. Yes. So it has a resistive touchscreen controller on the board. That's with the I2C, that's how we control it. There have been some tests done with capacitive touchscreen with LCD displays based on this board as well. And I think once those are more formal, we'll release those examples as well. So this is a good URL to remember if you need any help on this board in particular.
So just to put a plug in, everybody know Element 14 is Newark, Premier, Farnell, all combined together.
We have a lot of brands.
Element 14 is the kind of rebranding of Newark, the catalog house.
Yes, thanks.
And now it's a broader international reach. Really, they've done a great job focusing now on engineering support they probably have more NXP boards available to go buy than any of the other distributors or catalog guys out there. And they've actually gone so far as to generate a brand new board based on our part that only is available from their website. And that's what this combination is here. And at the price point, you can buy a high-tech board for $250 and add your own external LCD. You can buy a Kyle board for $300. It has a little LCD on it as well. Great choices. 120 is not a bad. Kick the tires, you know, you get both. So really, it's a great value.